Hi everyone, I'm Ellie Duncan. I'm a second-year PhD student on the Environmental Intelligence CDT, and my project is looking at natural aerosols in polar regions and how they affect the climate. So when I say aerosol, I'm sure the first thing that many of you think of is a spray can. And whilst this is an example of an aerosol, aerosol is actually a very broad term, just meaning a minute solid or liquid particle suspended in a gas. So today we're going to be talking about atmospheric aerosols. And there are many natural examples of sources of aerosols: volcanoes, chemicals released by trees, dust blowing in the air, and sea salt evaporating from the ocean. And there are also many man-made or anthropogenic examples. These tiny particles have a significant impact on various elements of our lives, from air quality and health, to visibility, to climate, and I'm mainly focused on the climate. But how do these particles affect climate? Well, if we think about increased emissions of greenhouse gases, we know that there's more trapped radiation, which leads to warming, whereas aerosols are thought to have a cooling effect through their interactions with clouds and scattering radiation. However, aerosols are one of the largest sources of uncertainty in climate modelling, limiting our ability to accurately predict climate. And this is particularly attributable to natural aerosols, which is why we focus on pristine regions such as the poles. Aerosols are very complex in terms of modelling. You can see in this simulation aerosols being transported around the world, and in this short time frame that's shown on the simulation, they can cover huge distances. So we really need to consider transport when we're talking about aerosols. So for my project, I'm looking at observations. So starting with a measurement station, for example, Zeppelin in the Arctic, we can measure the aerosols, but where are they coming from? They're not coming necessarily from local sources. They could be coming from a long way. So what we are focusing on is tracking the air to find where these sources of aerosols have come from. Using models and wind directions, we can track the air to understand where it came from before it reaches the measurement station. And this produces a trajectory, which is the blue line on the graph. And in order to understand the aerosol sources, we must consider the surfaces that the air passed over. Did it pass over ice? How long did it spend over ocean in this case? But to understand how much aerosol could be produced from these potential sources, we need to consider the meteorological variables. We need to think about the temperature, the wind speed, the relative humidity, the precipitation, and the list goes on and on. This builds a very complex picture, which we can't understand with traditional statistical methods. We need something else. We need a new method. So this is why I'm looking at using AI or machine learning techniques to untangle these processes to help us identify the significant sources of aerosols, as well as the processes associated with those. This in turn will help us improve climate models and therefore climate predictions, and help us inform policy. Thank you very much for listening.